optimize real-time control. I've had the pleasure of sitting through a number of talks in the last day and a half, and two common themes have stood out to me. One is around information and data. What happened during Hurricane Harvey? How and why did it happen? And then to whom it happened. And then the second theme that has proliferated throughout is how do we take that information and data and apply it to flood risk management? And looking at costs, approaches, methods, priorities, and working through different communities and policies. So my goal for this presentation is to map it into those two buckets, information and data, and flood risk management. I am not going to talk about Hurricane Harvey, but what I am going to talk about is how a community in Florida responded to Hurricane Irma last fall, and how that same technology could be applied to Harris County. So it's good, no one's walked out, given that I'm not talking about Hurricane Harvey. I want to start with this image. Picture yourself as a stormwater manager or an operator of stormwater management facilities, and it's September 7th, 2017, and Hurricane Irma is bearing up the coast in Florida, and you're asking yourself three questions. One is, what is the status of my stormwater assets or infrastructure? Meaning, what condition are they in? Are they ready for this large event that's about to hit? And as we all know, one of the challenges with stormwater assets is that they're highly distributed. And so, unlike some of the larger reservoirs you have here in Houston where there is real-time monitoring or staffing, a lot of these assets across the county are unmanned and unmonitored. So what is the status, and are they ready for a big event to hit? Preparation. What needs to be done in advance of the event? Obviously, public safety, evacuation, those types of things are important, but the stormwater managers, the people that are at the Emergency Operations Center, are also looking at preparing assets for the event. And then what resources do we need for emergency operations? And so this was sort of the real story of Hurricane Irma. And imagine how all of these questions would be answered differently if we had visibility into the assets that are distributed, and we also had decision support or automated control that could help us manage the event. So I'm going to come back to this. I'm going to give you a little bit more background and then come back to this event and tell you what happened during Hurricane Irma. And the case study is going to be centered around Ormond Beach, Florida. That's where the number 2 is in the circle, and it's right next to Daytona if you don't know where Ormond Beach is. Just wanted to address, when we look at flood risk management and traditional approaches of building detention basins and conveyance and other assets, some of the themes that we should be asking ourselves, and we did as a company at Opti, is how do we build these assets for resiliency and adaptation? As a civil engineer, I'm frustrated by the fact that we build things based on some synthetic event that may never happen. And as we learned yesterday, that 100-year or 500-year event is a moving target. It's continually changing and evolving, and these storms have a character in their own mind. And the other piece that's changing is our watershed. So urbanization, development is changing around us, but yet we're building static, passive infrastructure. How do we think about time to implementation? This is a big one as well. Post-hurricane, a large event, how quickly can we deploy resources and enhance infrastructure to prevent that from happening again in the future? And cost and land value and acquisition. Unfortunately, we don't have the flexibility of building out large detention facilities everywhere because we have people living in the watershed. So as a company, we looked at what's being done today and how can we look at these different factors and improve upon those practices. One example on that improvement is a little bit of the evolution of stormwater management, which I'm sure most of you are familiar with. On the far left, you have a traditional gray infrastructure approach, just building detention for peak flow control. In the middle is a conventional green infrastructure approach, where we're starting to look at triple bottom line, looking at aesthetics, heat island effect, and societal uplift. So what you're seeing here, by the way, what we're looking at is just a underground detention storage tank that would be common in a urban developed area. This conventional green and gray approach would be a bioretention or rain garden. And then we've taken it a step further and said, well, if we're already building out all these assets and spending millions or billions of dollars, can we add both monitoring and control to the outlets of these facilities to make them work more effectively? In other words, can we get more value out of the assets that we're already spending a tremendous amount of money on? And this is actually my first time to Houston, but I was told 2 days ago that one of the previous mayors did something similar for traffic signals. Apparently they synchronized traffic signals perfectly and reduced congestion. Is that true? Can anyone, if you ask him. All right. Well, it's a similar analogy here. Either we can expand our roadways or conveyance, or we can take those traffic signals and give them context or optimize them. Same idea. It's traffic control signals for stormwater flows and timing. So let me tell you a little bit about how this works. First of all, you need an asset. You need some sort of storage facility. This can be anything from a small rainwater harvesting rain barrel from 1,000 to 1,500 gallons to large regional flood control facilities. And most of these, as you may already know, are designed passively, meaning they fill up and drain down. No context of what's happening around them, what's happening with the weather, or what's going to happen in the future. So imagine we can use that storage and completely change the timing of when we need that storage, depending on our objectives. Our objectives could be flood control, so creating storage in advance of a rain event. They could be water quality, where we're maximizing the time of retention in the facility. Our approach is twofold. One is to implement hardware in the field that's commercially available. And water and wastewater treatment operators, if we have some in the room, know that this technology has been available for decades now. Actuated valves or pumps and level sensors and communication hardware. What hasn't been available is applying these cost effectively to a distributed stormwater asset. So our approach is to deploy a level sensor which monitors real-time levels, and it's a surrogate for storage capacity effectively. An actuated valve or pump, so in a gravity drain system, a valve would open and close to change the rate of flow and timing. And a control panel that communicates to a cloud-based software. And the reason we call it forecast-based control or adaptive control is we ingest NOAA's National Weather Service forecast in addition to what's happening in real time in the field to make smarter and predictive decisions around how to manage that storage most effectively for peak shaving, flood control, water quality, or multiple different objectives. So what Opti is doing is in real time thinking every minute or a couple of minutes, what's going to happen in the next 24, 48 hours, and how can I take action today or right now to minimize future impacts. And we talked about information and data. What comes along for the ride and what's inherently needed to control these assets is the level information, the valve status. And so we get direct visibility through web-based dashboards into the status of my asset. So if you think back to that first question I proposed to everyone when Hurricane Irma's coming, what's the status of my asset? Well, here's the answer. If we can see in real time what's happening, we know what the status is. Here's a shot of actual hardware that's deployed. Again, this isn't anything new necessarily, but the combination of the forecast and the way we're using the hardware is the innovative piece. On the left side here, you have a 18-inch actuated butterfly valve. Again, pretty standard component. On the top, you have an Opti control panel that could be powered by line or solar, and a water level sensor. Pretty standard components, but a couple things I want to highlight from these images. One is on time. We talked about traditional approaches. How do we implement and get outcomes faster? So this was a system that was applied to an existing detention facility. And you can imagine the retrofit is pretty straightforward. This is a couple days worth of time to add a valve, control panel, and level sensor, meaning we can deploy this hardware very quickly as an addition to an existing asset. And in terms of cost, this installation's in Beckley, West Virginia, where they spent hundreds of thousands of dollars to put in a detention basin, and this typically is on the 5 to 10% range of cost to do implementation. People always ask, well, Victor, what happens if that valve fails shut or doesn't open? We're civil engineers. We design for redundancy, and so if we lose power or cellular telemetry, there's always fail-safes in the system. And the easy example here is that this valve is only controlling a couple feet of level, and there's overflows, multiple bypass ways of the water to get out of the system. So back to Ormond Beach. Now that everyone is an expert in continuous monitoring and adaptive control, I want to show you what happened in Hurricane Irma. So first of all, the City of Ormond Beach has seen flooding events in the past. In 2009, a large hurricane came through and caused substantial damage, millions and millions of dollars, not unlike what happened here, Hurricane Harvey. They looked at what could be done post-2009, and what they found was in the center of the mess or the flooding, there was 5 existing recreational lakes in about a 500-acre residential neighborhood. And they said, well, we have this pump system at Lake 1. What if we interconnected all of these assets and used those pumps to draw down the facilities when the event hits? And that's what they did. They spent about $3.4 million hydraulically interconnecting all these lakes and using a pump, an older pump, to draw down the system. One of the challenges of this approach, although we get more capacity in a way, is that the pump system originally wasn't designed to handle that large of a drainage area. And so they were still continuing to see nuisance flooding when a big storm event hit, and these pumps were reactive and couldn't keep up with the rainfall event. And so they looked at what could be done next. So they have a great system in place. And one of their consultants proposed an $8 million conveyance and pump station upgrade. So they're right on the coast. They need to increase conveyance and the pump station. And for a small city, that's not an approach that was financially feasible. And so they asked the question, what can we do in the meantime and enhance, take this liability and turn it into an asset? And so that's where Opti comes in this, between this phase 1 and phase 2 phase. We sort of are considered a bridge or an insurance policy where we integrated the idea that these pumps could be operated more intelligently rather than local level logic where they turn on and turn off based on what's happening. Why not use these pumps before the event, for example, or at later time after? And so there were some upgrades, including our system and a VFD system. But the idea is that we take a large interconnected lake system that was really unmanned or unmonitored, provide visibility and intelligence to make it work harder and smarter, obviously at a much lower cost than the $8 million price tag to eliminate localized flooding. So the event, Hurricane Irma. This is a shot, this is real data from the event of our web-based dashboard. I'll just walk you through what it is here. On the top left, authorized users can take manual control, but typically the system is in automatic, meaning it's actually acting on its own. It's autonomous. It's looking at the forecast and the level to make decisions about when to release water to meet those specific objectives. So imagine having hundreds or thousands of assets. These would be difficult to control just by humans making decisions. So we have the weather radar. And then what this is just a simple 1-week plot of level in the lakes over the duration of the storm. And the critical piece here is that their permanent pool is at 3 feet elevation. And so Hurricane Irma coming through, we did a pre-event drawdown, which you can see from 3 to 2 feet. and then there was some inflow that came through, and then Hurricane Irma actually hits on September 11th here in the upswing. We have a small data outage, but the pumps are still running. And then the flood elevation here is at about 5 feet. And so what you can see is because of that drawdown, we actually eliminated some of the nuisance flooding that would have happened. At one time, we saw NOAA was forecasting for about 13 or 14 inches in this region, and Ormond Beach was lucky to end up getting 8.4, which is not uncommon for them. So the city asked Opti to look at what would have happened had we not implemented forecast-based control and get visibility into the site. And that's what the plot here is in red. This is a modeled sort of summary of their existing system before Opti forecast-based control was implemented, and the blue is the observed data. That's what actually happened. And what you'll notice is for this event, there would have been some nuisance flooding likely in the area had we not dropped the lake levels about a foot well in advance of the event. So a success story. I wanted to show this. We're starting to see a trend of wastewater utilities or other stormwater emergency operations center where they're not just looking at large centralized assets, but they're also adding dashboards on their distributed stormwater infrastructure. So this is a shot from North Hudson Sewerage Authority in Hoboken, New Jersey, where they're monitoring a 250,000 gallon detention basin and seeing what's happening and what capacity is available and how they may want to alter that automated logic to help with their wastewater treatment operations. You may also be wondering, what about other contexts or other downstream conditions? And I wanted to show an example that at scale, Arturo, I think, mentioned this yesterday, is we have to look beyond just what's happening at that site and maximize the volume at that site. We need to look at downstream flooding or how other assets are performing. So I think that's one of the biggest opportunities. How do we get distributed infrastructure to work together rather than maybe even have negative consequences in some case? So in Albany, New York, we have multi-site deployments where we have, I think, around 3-4 million gallons under management. And these upstream assets are being automatically controlled for combined sewer overflow prevention. So we're trying to retain as much water during wet weather in the systems as possible. And what we're adding is downstream level monitoring that can also be incorporated into the decision-making logic. So although there's storage capacity available up in the watershed, maybe don't release it because we have downstream congestion. Again, back to the traffic control analogy. So it's when we start getting these systems working together where we can truly see system-wide watershed benefits. So Houston, I did tell you I wasn't going to talk about Hurricane Harvey, but I wanted to share maybe what the opportunity here is in Harris County. We did a quick digitization of the area here and found that there's about 10,000 existing dry and wet detention basins across the region, which is an opportunity. I mean, I think this is good news. There are a lot of existing assets, and we're not here claiming that we're creating storage volume or, there's obviously some mass balance and timing and other things that we need to consider, but there's assets here in terms of getting closer to flood risk management or mitigation. There may be some low-hanging fruit on the watersheds that we can get more value out of. And you'll notice, obviously, the bullet point here, 45% of these ponds are within the 100-year FEMA flood zone. Here's a zoom of one of these existing wet detention basins. And obviously, they're controlled either by gravity or may have some other restrictions that we might want to look into. I just wanted to mention one other thing. I had a conversation with a gentleman in the back that we're finding that cities aren't able to accomplish flood risk mitigation or stormwater management on public right-of-ways alone. And so we're starting to see a lot more around alternative delivery strategies where we're leveraging private assets for public good. And so you can imagine out of the 10,000 assets, Many of those, if not most of those, are likely on private property. And so how do we gain access to those assets and get more value to help the city or the county more broadly? With that, discharge, and it's a tidally influenced estuary, but some of this is done so far in advance where there may not be those impacts, but they're lucky to be on the coast. But certainly in landlocked communities or other places, the strategies need to be different. But I think it's important to recognize that right now we have no control, right? These assets are just sort of doing whatever. We're not even quite sure. And so taking that and gaining information and maybe some level of improvement is a step forward. Sure. Well, first of all, it's a phased approach. So it's not that you're controlling all 10,000 at once. These pilots grow, and we look at priority areas typically with our communities. So where are we going to get the highest value, maybe lowest risk impact, and grow it from there. Again, like I said, we're civil engineers. Although we want to minimize flooding, public safety is number one. And so making sure that we have structural fail-safes, and under worst case scenarios, we're not doing any worse than what was already put in place. Yes.
When you took the pond down one foot, was that enough? And what went into figuring out how much you had to drain out of the ponds?
So first question, was that enough? And so this blue line here showed that we were well below the flood elevation. And so yes, it was enough. And what goes into figuring out how much is two factors. One is looking at the NOAA National Weather Service and looking at the quantity of precipitation that's expected to run off the watershed area in the next 24 or 48 hours. And then looking at what storage capacity is available at the site. And it's really just a mass balance where we're looking at what's expected to come in and what capacity do we have available. And so in this case, like I mentioned, at one point NOAA was forecasting 13 or 14 inches, where that's what we were preparing for. And people always ask, well, what if the forecast is wrong? Well, it depends which way you're wrong and how conservative you are. So this site is designed to be overly conservative, meaning if we think we're going to get an event, let's drain it down, because worst case scenario, the residents have they're at 2 feet instead of 3, and it'll fill back up over time.
So the picture you had of Ormond was previous?
Yeah, that was 2009. Yes.
I had a question. If you look at your drawing and you made the comment that the discharge was, when you lowered the water level in that pond, you discharged it to the ocean. Is there anything that would prevent you from discharging ahead of time into a river system? I guess the one thing would be if the flood's coming upriver, then you're going to have trouble.
Yeah.
But if it's from some other source, or discharging this June 1st is the beginning of the hurricane season, let's draw them down. Problem is now in August, you want the water for the front yard, and it didn't rain.
Yeah.
So these are other problems you have to deal with when you're going to try to pre-drain, aren't they?
They are. You're absolutely right. So even here, they have some tidal impacts as well. So that's why it depends what we're trying to manage for water quality or flood control. We're trying to look further out to try to minimize other issues. But yeah, that's why we need this multi-site coordination, is what's happening downstream so that we don't create any adverse effects. This is a fail-safe or a secondary insurance policy, if you will. Yes.
1 minute.
Yeah.
I want to follow up on the question that was asked about the capacity for some degree of interference in the software and so forth. So with the type of system that y'all are talking about here that you've been working with, what is the largest system that you've worked with so far? In other words, here this image is showing 2 ponds and 1 discharge.
Yeah, this one, it actually has 3. Hanson and Reichman are 2, and then there's a lake that's draining into a combined
so
sewer.
By comparison with the 10,000 ponds and the 74,000 districts that exist in Houston, Harris County, what's the largest system that you all have tried something like this on so far?
I think we're in the 10 to 15 range with a city and municipality and growing. So with Albany, for example, we're looking at another 3 sites this summer. And so like I mentioned earlier, it's a phased approach where they had a lake that was draining right into the combined sewer. And so that was the easy one. Okay, why don't we discharge during dry weather and then sort of move our way? So it's a phased in approach. And as a company, we've been around for about 5 years now, and so we're growing our footprint, and we're deployed in about 22 states and 130 sites globally that are operating like this for different objectives and different challenges.
Do you ever think about treating the water and using it? You know, we were talking about Houston in the summer, and maybe you don't treat it very much for irrigation, but, you know, treating it for use in the, you know, people's houses.
Yeah, we have many sites that are water reuse facilities, and which is the beautiful example for this is a rainwater harvesting system. You want it empty for a storm that's coming, but you also want it full for reuse. And so these are actually competing objectives where this technology can only draw down for irrigation or other things just the amount that you need to maximize water reuse and stormwater management. So yes, sure. Design it very carefully and over time. I mean, part of this is learning, right? You'd be surprised how many times we have engineers that design and model a system and how it's supposed to behave. And then when we implement our monitoring equipment, we realize that watershed areas may be off by an order of magnitude, for example, right? So it starts with getting visibility into the assets, understanding what's happening. I mean, that was one of the themes from yesterday. What actually happened? Where were the flood elevations? What were the impacts? So getting information and then using that information and applying it more autonomously. I wish I could give you a direct answer. If City of Houston or Harris County give us an opportunity to look into that, we would love to. We just submitted for Houston Water Innovation Hub, where we're hoping to pilot this technology and actually see what is the watershed scale applicability of this. So don't know yet, but we think there's an opportunity.